There is a place in the southern sky that appears to be nothing more than a bright, steady point of light. Yet that familiar beacon belongs to an entire stellar system, and perhaps the nearest collection of worlds humanity may one day reach. Alpha Centauri lies roughly 4.3 light-years away. In cosmic terms, it is almost next door. In human terms, it is unimaginably distant. Its light crosses nearly 40 trillion kilometers before reaching our eyes, carrying an image that is already more than 4 years old. Even our fastest spacecraft would need tens of thousands of years to make the journey. And still, astronomers return to this system again and again, because proximity changes everything. Every telescope gains more detail. Every faint signal becomes more valuable. Every possible planet becomes a destination rather than a statistic. At its center are two sun-like stars locked in an ancient gravitational dance, while a dim, red companion travels through the darkness far beyond them. 3 stars, different in size, temperature, and temperament, bound within the same cosmic family. But if our nearest stellar neighbors are already this complex, what might be hiding in the darkness around them? At the heart of the system are Alpha Centauri A and Alpha Centauri B, 2 stars so familiar that from the right distance, either could almost be mistaken for our own sun. Alpha Centauri A is slightly larger, brighter, and more massive than the star that warms Earth. Alpha Centauri B is smaller, cooler, and more subdued. Together they orbit a shared center of mass in a cycle lasting nearly 80 years. Their separation changes dramatically as they move, sometimes drawing relatively close, sometimes retreating toward distances comparable to the outer reaches of our planetary system. From a planet orbiting one of them, the second star would not be a distant speck. It could shine like an extraordinary celestial beacon, altering the night sky and casting a second rhythm of light across the seasons. For decades, scientists wondered whether the gravitational pull of 2 stars would make planetary orbits too chaotic for stable worlds. But simulations revealed something more intriguing. Within the right regions, planets could survive for billions of years. Stability is possible. Habitable zones may endure. And if planets formed there, the nearest Earth-like horizon may not circle one sun, but exist beneath 2. So why have those worlds remained so difficult to find? Far beyond the bright central pair lies the system's smallest member, and the star that is technically closest to Earth. Proxima Centauri is a red dwarf, faint enough to be invisible without a telescope, yet important enough to transform the search for life beyond the solar system. It contains only a fraction of the Sun's mass and produces far less visible light. But small does not mean quiet. Red dwarfs can be magnetically violent, releasing powerful flares and bursts of high-energy radiation. Proxima is separated from Alpha Centauri A and B by thousands of astronomical units, moving through an enormous orbit that may take hundreds of thousands of years to complete. From its distant position, the 2 brighter stars would appear as a close pair in the sky, a reminder that even within one system, space can be vast. Yet Proxima's dimness creates an unexpected advantage. Because the star releases so little energy, its temperate region lies extremely close to it. A planet would not need to orbit at Earth's distance to receive enough warmth. It could circle in days rather than years. And in 2016, astronomers found evidence that exactly such a world exists. But was it a second Earth, or a planet trapped beside a dangerous star? The world is called Proxima Centauri b. Its known mass is close to that of Earth, and it completes an orbit in only 11.2 days, traveling at roughly 5% of the distance between Earth and the Sun. Under ordinary circumstances, such a planet would be scorched. Around a cool, red dwarf, however, that tight orbit places it within the region where liquid water could theoretically exist, if the planet has the right atmosphere, pressure, chemistry, and history. That possibility made Proxima b one of the most compelling worlds ever discovered. But the phrase habitable zone can be dangerously misleading. It describes where water might remain liquid, not whether life is present, or even whether the planet is truly habitable. Proxima Centauri erupts frequently. Ultraviolet radiation and X-rays may have battered the planet for billions of years, possibly stripping away part or even all of its atmosphere. Its close orbit may also have affected its rotation, potentially leaving one hemisphere beneath permanent daylight and the other in endless night. Yet even these extremes do not completely rule out survival. A thick atmosphere or global ocean might redistribute heat, while magnetic protection could reduce atmospheric loss. Somewhere between burning daylight and frozen darkness, a narrow twilight region might remain stable. The question is no longer whether Proxima b is nearby, but whether anything could endure there. Proxima b may not be alone. Additional signals have been associated with other possible worlds, including a tiny inner candidate known as Proxima d, and a much more distant candidate called Proxima c. But in exoplanet science, a signal is not the same as a planet. Stellar activity can imitate orbital motion. Instruments can create patterns that disappear under closer examination. The history of Alpha Centauri is filled with discoveries that became mysteries, and mysteries that later became false alarms. Yet the search around its two sun-like stars has entered a new era. Earlier observations revealed a tantalizing source near the habitable zone of Alpha Centauri A, but scientists could not determine whether it was a planet, dust, or an instrumental artifact. Then the James Webb Space Telescope found stronger evidence for a giant planetary candidate orbiting the closest solar twin to Earth. If confirmed, it would not be another Earth. It would most likely be a cold gas giant. But even that discovery would transform our understanding of the system and reshape the search for smaller worlds that might share its neighborhood. The nearest stellar system may already contain more planets than we can see. And if a giant world can hide within the glare of Alpha Centauri A, what else is still concealed beside it? To imagine life in Alpha Centauri, we must abandon the assumption that another living world must look exactly like Earth. A rocky planet around Alpha Centauri A could receive sunlight remarkably similar to daylight on our world, while Alpha Centauri b glowed as a brilliant companion in its sky. A planet around b would experience a cooler primary sun, with the brighter A rising and setting across a slowly changing stellar landscape. Seasons could be influenced not only by axial tilt and orbit, but by the long movement of the binary pair itself. Yet the same gravitational complexity that makes the system beautiful also places strict limits on where planets can remain stable. Too far from one star, and the companion's gravity may disturb the orbit. Too close to the shifting boundaries of stability, and tiny gravitational changes could accumulate across millions of years. Still, nature has repeatedly shown that planets can form in environments once considered impossible. The question is not whether Alpha Centauri resembles the solar system. It does not. The deeper question is whether life requires a familiar sky at all. Perhaps biology can emerge beneath two suns, beside a restless red dwarf, or on a moon circling a giant world. Alpha Centauri is close enough for us to test those possibilities, not with imagination alone, but with observation. And for the first time, the next step may involve more than telescopes. The distance to Alpha Centauri is both small and enormous. A beam of light can cross it in a little more than 4 years. A spacecraft built with technology similar to today's deep space probes would require tens of thousands of years. That gap defines the central problem of interstellar travel. The universe is not unreachable because the stars are invisible, but because our machines are slow. One of the boldest proposed solutions is breakthrough starshot. Instead of launching a massive spacecraft, the concept imagines tiny electronic probes attached to ultralight sails. An immense ground-based laser array would strike those sails with concentrated light, accelerating them to a significant fraction of the speed of light, possibly around 20%. At that velocity, a flyby of Alpha Centauri could occur in roughly 2 decades rather than many millennia. But the elegance of the idea hides brutal engineering challenges. The sails must survive extreme acceleration. The probes must navigate interstellar dust at extraordinary speed. Their instruments must function after years in deep space, collect valuable data during a rapid encounter, and transmit a faint signal across more than 40 trillion kilometers. It is not yet an interstellar mission. It is a test of whether human engineering can escape the limits of its birthplace. And if it succeeds, what will the first image from another star system reveal? Alpha Centauri matters because it transforms the abstract into the possible. Most stars are so distant that they exist only as remote points in maps and catalogs. This system is different. Its light reaches us within a human timescale. Its planets can be studied with the most powerful instruments now being built. Its distance, though immense, is close enough to inspire real engineering rather than pure fantasy. It is a natural laboratory. Two sun-like stars sharing a gravitational dance, a volatile red dwarf moving through a vast outer orbit, at least one confirmed Earth mass planet, and several unresolved clues waiting for better evidence. Somewhere within that complexity may be a barren world, an ocean hidden beneath clouds, a lifeless giant, or a landscape shaped by conditions we have never imagined. Even the discovery of simple microbial life would challenge one of humanity's oldest assumptions. that life on Earth may be a singular accident. But perhaps Alpha Centauri's greatest importance is not what we will find there. Perhaps it is what the journey will force us to become. A civilization capable of looking beyond its own sun, building machines for destinations no human has ever seen, and thinking in centuries instead of years. The nearest stars have been waiting since before humanity existed. The real question is whether we are finally becoming capable of reaching them.